Here we are in August of 2025, and I'm still seeing a lot of developers working for major American companies that are still using type any in their TypeScript code bases. Now, these are not all TypeScript code bases that I'm seeing, but TypeScript projects that were started within the past 18 to 24 months with all of the tools and resources that we software developers currently have at our disposal. There's really no need to use type any. When you use type any, you're telling TypeScript to go take a lunch break. There's nothing to see here, TypeScript. There are no missing Epstein tapes. The more type any that you have in your code base, and the longer you delay refactoring the code base to properly use types, the more complicated and expensive in terms of cost the refactoring is going to be in the future. Now, the short-term contractors or short-term employees are not going to care about this. But people who are accountable for the project and the people that are working there long term, or the people that will be inheriting the project, they will be the ones that will have to deal with the consequences of other developers' laziness. Which begs the question, why even bother using TypeScript to begin with? And in case you're not aware, TypeScript is syntactic sugar for JavaScript that has become insanely popular. Some companies and some development teams adopt TypeScript without truly understanding the responsibilities of using TypeScript in a big project. But that's a story for a different video. One alternative to using type any are generics, which have been available since TypeScript 3, which was released in July of 2018. And as you can see here from the refactored code to using generics, the amount of code that we have to type out has not increased that much. Here's another example of a refactor. In the original version, we are clearly better off just using vanilla JavaScript. And here again is another easy refactor for an easy win. The type for T will be determined at function invocation time. TypeScript will infer the type for type T from the arguments or uses the explicit type the programmer provide. On line 20, that will be a number, and obviously on line 21, that is a string. So just to drive the point home, this type checking is done by the native IDE itself, not from any AI agent. So then this is what the generic would do for us. Obviously, in the first case, we're missing any argument, so it'll tell you that. Now, in the case of an object literal, that's what T has become. And then in the case of a number, T is a number type. Of course, your string. In the case of destructuring and then merging objects, if we use the any type like we are doing here, we would have to manually cast the data. Manual casting in this case means you have to use a type assertion, like here, like I'm doing on line 14, to tell TypeScript what the shape is, because any disable the inference, the type inference. And here we have the refactor function with more clarity. The usage of the capital letter T and the capital letter U are just traditional convention. They can, in fact, be whatever your team decide it to be. Your team and all the teams within your company. For example, here in my use case, I'm using N for name, A for age, and M as a Boolean for marital status. Generics are also flexible enough for me to reuse this pattern to have a union type, as you can see here on line 13. So now the marital status can either be a Boolean or a string. We can also restrict the marital status to only being true or false. Now, some developer will see the extends keyword on a type and go, yes, it's true that the keyword extends in TypeScript is often associated with interfaces. But there are two other instances where we can use the keyword extends in TypeScript, and that is for generic constraint. Here, I've given you the example in this slide that I made for you, and in conditional types, as you can see down here below, and I give you an example of how to use that. If you're having fun so far in this video tutorial, and if you're learning new things, please consider subscribing to my channel. It is completely free. It doesn't cost you anything at all and will help me out in the future. Please also consider giving this video tutorial a thumbs up or a like. Thank you again. A complaint that I hear from developers who do not come from a traditional programming background in a language that has types is that generics are hard to read. For example, the type relationship in this function signature. My best advice to you would be to break things down in simple chunks. For example, this map values function will have a type T and a type U. Its types will be declared at invocation time, like I mentioned earlier. If we were to ignore all the typings and the generic in this function signature, we can see that we're simply passing in two parameters, an object literal and a function. And of course, in vanilla JavaScript, you can pass a function to a function as a parameter. That is a typical functional programming pattern. Record is a keyword in TypeScript for objects, object literals. And we will have the key be a string. Now, of course, in JavaScript, in vanilla JavaScript, in an object literal, all keys are string. That's just a JavaScript thing. And the values will be of data type T. Again, just to drive the point home, in a JavaScript object literal, all the keys, no matter what it is, behind the scene, they are always string. So this bit here is just to reinforce what the type are going to be for these parameters. That's all they are, rather than just using an any. And it's the same thing for this function. This function will take type T as its parameter, and then will return a type U as we specified here. And then the function itself will return a record of string and type U as its value. Again, we know why there's a string in object literal. So all of this, again, is to reinforce in our brain, in our developer brain, of what the shape of the return data will look like, what the parameter is supposed to look like, and what the function is all about. This appears at first glance to be difficult to read, but in actuality is to help us to understand what this function is and what it's going to return. Now we are going to do a few examples of converting any types over to generics within a React application. We are using 10-stack query to fetch data from an API endpoint. And even though we are using TypeScript for this project, this query has no type definition. And if we were to hover over the return data, it's returning the data has an any data type. If we were to go with this pattern, then we might as well just be using vanilla JavaScript. If we were to add a type for the user and then pass that type as a generic to the useQuery hook, look what happens when I hover over the data. See, it's returning the user type or undefined, as it should. So this is a quick win right here. Again, this is relatively easy to refactor based on what we've learned so far. And if we were to use this list component to list out, say, a list of products, then it would look like this with types instead of any. Now let's refactor this higher order component that is using any data type. So at first glance, your first reaction to the refactored code is, holy cow, why so much more code? First of all, we have more code because we are supplying more precise typing. The whole point of using TypeScript is to have a better understanding of what each line of code is doing so that there are no runtime surprises. And we can have confidence when we refactor the code or when we onboard new software engineers, new developers onto the team. The question I always get asked is, why do we need this wrapped? Isn't it rather redundant? So remember that we are currently in a React TSX file. Return types in TSX or React JSX can be very janky, very brittle. So by doing this, we are explicitly typing the return type. And then we can declare wrap.display name. And when you use the React Dev tools in the console, if you look in the component tree, it'll say this wrap.display name instead of like an anonymous component, which is absolutely useless for debugging. And if you use stack traces and profiling tools or other dev tools, wrap will show up in those stack traces instead of anonymous, which again doesn't do anything for you. Finally, I want to talk about unknown abuse. I've seen this type being abused a lot. Make sure that when you use unknown, that is exactly the type that you need. Most of the time, people use unknown as sort of like a substitute for any, when in fact they should be declaring a generic for their data type. I'm not saying not to use unknown, but make sure that when you use unknown, it is indeed an unknown condition or unknown data type. Okay, my dear friends, I hope this has been helpful and somewhat entertaining. Please consider subscribing to my channel. Please consider giving this video a thumbs up if it was beneficial for you. Thank you for watching. I'll see you next time. Bye for now.